Today we are going to discuss about gravitation. What is gravitation? When the object is lying on the Earth's surface, the object is attracted by the Earth and the force of attraction is actually gravitation. There is a universal law of gravitation. Here in this diagram, the first object is with mass m1 and the second object is with mass m2, and the distance between these two objects is d. So the force of attraction, the gravitation, the force of attraction is proportional to the product of masses of two objects and inversely proportional to the square of the distance between these two objects. So by this process we can say force of attraction is the product of gravitational universal constant product of masses of two objects and is divided by the square of distance between two objects. So F is equal to capital G m1 m2 by d square, where capital G is the universal gravitational constant, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square. It is the SI unit of universal gravitational constant. And what is that? When moon is moved around the Earth, there is a force of attraction which is provided by the Earth, the force of gravitation, and this type of force is centripetal force. In this diagram, if there is no centripetal force, the moon will move along a straight path. The orbit is here elliptical. Okay, moon can move around the Earth by the centripetal force. There is a presence of force which is called centripetal force. Okay, now I am going to discuss about the planetary motions law, which is provided by Kepler. There are three laws. Okay, first law, second law and third law. First law is what? That when planet is moving around the sun, the orbit shape is elliptical at any one of the foci. The second law is what? In this diagram, we all can see when planet is moving from position A to position B and then position D to position C, the time taken by the planet from A to B 1 month, from D to C 1 month. So here OAB, this center is O. OAB area is equal to the OCD. So we can say planet can sweep out equal amount of area in equal interval of time. So we can say OAB area is equal to area of OCD. In this diagram, we all see it clearly. Okay, the third law is what? The mean distance between the sun and the planet, the cube of mean distance between the sun and the planet is proportional to the square of time taken by the planet to complete one orbital circular path around the sun. Okay, RQ proportional to T square. So this is all about the Kepler's planetary motion, and the point in the orbit which is farthest from the sun is aphelion. The point in the orbit which is nearest to the sun is perihelion. These two types of points we can say in this figure. This is aphelion and this is perihelion. So the next point is free fall. What is that? In this diagram, we all see that the planet is the object is falling without any friction towards the Earth. Is Earth's surface, and this is the layer of Earth's surface. The object is present here. The center is here, and the distance between the object and the center is capital R. So when the object is falling without any friction towards the Earth, the force of gravitation is there. The acceleration is occur due to the acceleration to the gravity. Okay, and this type of motion of the object is free fall motion. From this, we can say, we told before that the universal law of gravitation. What is that? Force of attraction or gravitation is equal to the product of universal gravitational constant, mass of Earth, mass of object is divided by the square of the distance between the object and the center of the Earth. Okay, R square. And we knew that from the second law of motion, Newton's second law of motion, we knew that the force of attraction or the force applied on the object is equal to the product of mass of the object and the acceleration. Here acceleration is the acceleration to the gravity, so here it is written as small g. So combining these two formulas, we can see that this acceleration to the gravity is the product of universal gravitational constant mass of earth is divided by the square of the distance between the object and the center of the earth. So from this formula we can see that this acceleration to the gravity is not dependent on the mass of the object but dependent on the mass of the earth, and the amount of the acceleration to the gravity is 9.8 meter per second square. So in the next stage we can say that mass and what is the weight. Mass is actually the content of the body, and this is a scalar quantity. The SI unit is kilogram, and weight is the force by which the object is attracted to the center of the earth. So this weight is equal to the force, and this is a product of mass and acceleration to the gravity. And combining these formulas, we can tell that this is the product of universal constant of the gravity, mass of the earth, mass of the object, and divided by the distance between the object and to the center of the earth. So capital G, capital N, small a divided by capital R square, and the SI unit is in 1 kg, weight is equal to the 9.8 Newton. Okay, so this is all about mass and weight. The next portion is thrust and pressure. Do you know what is thrust? What is the difference between thrust and pressure? Actually the force applied on the object, and this is a perpendicular way, and this is thrust, and thrust is a thrust is a vector quantity, and the SI unit is Newton. But on the other hand, the pressure is actually the ratio of thrust to the area. Thrust by area is pressure. Actually pressure is inversely proportional to the area. When pressure is low, the area is huge. In the huge area, the pressure is low. In the small portion of area, the pressure is high. This is the main fundamental feature about the pressure, and this is actually a scalar quantity, and this is what the SI unit is, Newton per meter square. Okay. The last portion of our today's discussion is upthrust and factors which have special impact on the upthrust. What is upthrust? And first of all, I will tell that the liquid has a tendency to give upward force to the object which is immersed into the liquid. Okay, object is immersed into the liquid, and the liquid has a tendency to give a upward force to the object, and this type of upward force is called upthrust or the buoyant. For the tendency of the liquid is the buoyancy, and there are some factors which show a special effect on this buoyant force or upthrust. What are they? The density of the liquid. The density of the liquid is proportional to the upthrust. When density is huge, density is high, the force is also high. When density is low, force is also low. The upthrust is also low. The next is the volume of the object. The volume of the object is actually proportional to the upthrust. When volume of the object is huge, just like ship, the upthrust force is also high. That's why the ship can float in the surface of the water. And on the other hand, when the volume of the object is low, the upthrust is also low. That's why the small ball can easily immerse inside the liquid. Okay, here I am discussing about a specific diagram. Just follow this diagram. Here this downward force is actually weight of the object, and upward force is actually the upthrust. When this downward force means weight of the object is very huge, very high, okay, this will help to sink the object. The object will sink. When upward force, upthrust is high, this will help to rise the object, and the object will rise and object will float in the surface of the water. But when this downward force means weight and upward force means upthrust are equal, these two force when equal, this will help to float the object in the liquid. Okay, neither it will sink nor it will rise in the surface of the liquid. Okay, thus it will float inside the liquid. Okay, the last part is the special form principle. We should notice this Archimedes principle. Actually, what happens when a body is immersed in the liquid, actually it displaces some amount of liquid. Okay, and liquid has tendency to give a upward force means buoyant force or upthrust to the object. Okay, the amount of upthrust, the amount of buoyant force given by the liquid to the object is equal to the amount of liquid displaced by the object. Okay, this is the main formula of principle of Archimedes. Okay, by this, using this principle, we all can say the ball can easily immersed in the liquid and the ship can float in the upper surface of the liquid. So this is all about my today's discussion. First of all, gravitation, the universal law of gravitation, Kepler's law of planetary motion, free fall, acceleration to the gravity, mass, weight, thrust, pressure, and lastly upthrust and Archimedes formula. I think this all discussion is going to be very much useful to your studies. If you like this video, go to the Play Store, download Knowledgeflame app, and please subscribe to Knowledgeflame channel. Thank you.